Nuclear fusion. Are we finally close to star power? Imagine an energy source so powerful, a cup of fuel could power your home for hundreds of years. No carbon. No long-lived radioactive waste. Just clean, limitless energy, like the sun. That's nuclear fusion. For 70 years, it was always 30 years away. But in 2022, everything changed. Scientists finally achieved net energy gain, more power out than in. So, are we on the brink of a revolution? Or is fusion still a distant dream? What is nuclear fusion, and why does it matter? Fusion is the process that powers stars. It happens when light atoms, like hydrogen, are squeezed together under extreme heat and pressure, forming helium and releasing massive energy. Unlike nuclear fission, which splits heavy atoms and creates dangerous waste, fusion uses seawater fuel, produces no meltdown risk, and leaves only short-lived radioactive byproducts. If we can harness it, fusion could end our reliance on fossil fuels forever. The biggest challenge: containing a mini-sun on Earth. To fuse atoms, you need temperatures hotter than the sun's core, over 100 million degrees Celsius. At that heat, matter becomes plasma, a swirling, electric soup that melts any physical container. So scientists use powerful magnetic fields or lasers to trap it. But keeping the plasma stable, dense, and hot long enough for net energy? That's the holy grail. For decades, fusion experiments used more energy than they produced. The breakthrough, net energy gain, 2022 to 2024. In December 2022, the National Ignition Facility, NIF, in the US made history. Using 192 giant lasers, they blasted a tiny fuel pellet, and got 3.15 megajoules of energy from just 2.05 megajoules of laser input. Net gain. They've repeated it multiple times since, with higher efficiency. But NIF's method isn't designed for power plants, it's for weapons research. The real race is in magnetic confinement. ITER, the giant international experiment in France, 35 nations are building ITER, the world's largest tokamak, a donut-shaped magnetic reactor. When operational, now delayed to 2035, ITER aims to produce 500 megawatts of fusion power from just 50 megawatts of input, a 10x gain. But ITER won't generate electricity. It's a science demo. And it's plagued by delays and cost overruns, now over $22 billion. The new hope: private companies move faster while governments build giants. Startups are betting on smaller, smarter designs. Commonwealth Fusion Systems, backed by Bill Gates, uses new high-temperature superconductors to build compact tokamaks, aiming for a pilot plant by 2030. Helion Energy, funded by Sam Altman, fuses hydrogen and helium in a pulse system, and plans to sell power to Microsoft by 2028. K Technologies pursues a neutronic fusion, targeting direct electricity conversion. These companies raised over $6 billion, and they're racing to be first to the grid. So, when will fusion power our homes? Most experts say the 2030s for first grid connections, if materials, funding, and physics cooperate. The US and UK now have government programs to support pilot plants by 2032 to 2035. But challenges remain: plasma instabilities, neutron damage to reactor walls, and tritium fuel scarcity. Fusion won't solve climate change in the next decade, but it could be key for the second half of the century. The bottom line: fusion is no longer science fiction. It's an engineering marathon. We've proven the science works. Now, it's about speed, investment, and innovation. As one physicist said, fusion is the energy of the future. And always will be. But for the first time, that future might actually be in sight. If you're amazed by human ingenuity, like, subscribe, and tell us, will fusion arrive in your lifetime?